In this lesson and the next lesson, we will introduce descriptive measures of association between two variables, the covariance and the correlation measures. Understand them and introduce their Excel commands. In the past lessons, we studied two categories of descriptive statistics, measures of central tendency and measures of dispersion. To recap, descriptive statistics or measures are a summary set of numbers that describe the multiple observations in a data. The descriptive statistics on central tendency that we covered were the mean, median and the mode, while the descriptive measures of dispersion or spread in the data were the range, interquartile range, standard deviation and variance. These are the two primary measures of descriptive statistics. These measures summarize the multiple observations on a single variable. For example, what is the mean height of men in your neighborhood? What is the median house price in your city? What is the standard deviation of dollar order received at the online grocery store, data from which we have used in past lessons, and so on. All these examples consider multiple observations on a single variable, the height of men, the house price, the dollar order. Another set of descriptive measure of data, rather than looking at a single variable, considers the covariation amongst two variables. That is, how do the two variables vary together or co-vary. These measures are called measures of association, and they describe in a set of numbers the relationship between two or more variables. We will now introduce and understand these measures. Let us take another look at the scatter plot constructed in one of the lessons in the first course in this specialization on business statistics and analysis. The first course introduced the use of Excel for analyzing data, and in a particular lesson we constructed a scatter chart, also known as a XY plot. A scatter chart is a visual representation of the relationship between two variables, and we analyze the relationship between the height and weight of certain Olympic athletes from a recent Olympic Games. Heights being represented on the horizontal axis and weights on the vertical axis. Not surprisingly, the pattern of the scatter plot visually indicates that there is a positive relationship between the height and weight of an athlete. That is, as height increases, so does weight. A descriptive measure of association attempts to numerically quantify this relationship. That is, in a set of numbers, describe this relationship. We will study two such measures which are closely related, the covariance and the correlation. First, let us look at the covariance, the formula for which is as shown. Uppercase X and Y are the two variables for which the covariance needs to be calculated. Lowercase n is the total number of observations on each of the two variables. Subscript I indexes each of those n observations. The horizontal bar on top of the variables indicates the mean value for that variable. As mentioned in one of the previous lessons, there is a slight variation in formula depending on whether you are considering the entire population of data or a sample of data from some population. For sake of simplicity and uniformity, throughout this specialization, we will use the sample formulas. Accordingly, the Excel formula that we use is covariance.s open parenthesis, and then we type in the two data ranges for the two variables. Remember, you need to have the same number of observations in the two data ranges. Let us calculate the covariance between the height and weight of these athletes in Excel using the file heightandweight.xlsx. The first two columns of the file are the name of the athlete, then you have the height of the athlete in centimeter, then the weight in kilogram, the country to which the athlete belongs, and the gender of the athlete. So given this data, what we are interested in is in calculating the covariance between the heights and weights across these athletes. So covariance between height and weight, and we'll calculate that using the covariance.s command in Excel. So is equal to covariance.s open parenthesis, then I select the two data ranges, height and weight. It does not matter whether I select height first or weight first, we'll get the same answer. So I begin by selecting the height data range, C2 all the way to shift control down arrow, which gives me C1588, comma. Now I enter the second data range, the weight of the athlete, D2 through D1588, close parenthesis. So that completes my covariance formula. Covariance.s, the first data range, height, the second comma, the second data range, weight. I give an enter, and the answer I get is 139.9856. The unit of this covariance is the product of the units of the two data ranges. In this case, centimeter times kilogram. And the important thing to note about this covariance measure is that the sign of this measure is positive. It indicates that there is a positive relationship between height and weight of the athlete. As heights increase, so does the weight, and as heights decrease, so does the weight decrease.